Hello, learners, and welcome back to our series on pre-calculus topics, kind of priming you to get ready for AP Calculus, or maybe you're taking Calculus Honors, or maybe you're at the university or college level taking a calculus course. But anyways, welcome. I appreciate you tuning in. Today, what we're going to be talking about is this concept of piecewise functions. And a piecewise function, if we were to see it graphically, let's take a look here really quick. Kind of looks like number 5. So it's a function that has different pieces to it. So for a certain range of x values, or a certain range, how do I say this? For certain values on its domain, it may be linear or quadratic or cubic or even, non-algebraic. So it could be trigonometric or exponential. And then for another piece of its domain, it's kind of something else. And the reason we study this in calculus so much is because it comes up in the limits unit when we discuss continuity, when we discuss one-sided limits. And it's just kind of a good thing to know before you are thrown into a calculus course. So specifically what we're going to do today, we're not going to focus on graphing or analyzing the graphs. We're going to purely be looking at problems that are giving us a piecewise function such as g of x and h of x, as you see here, and evaluating these piecewise functions at the point specified in the problems. So let's start off up here, finding the value. So I'm given f of x is equal to, and then you see this nice little curly bracket. We're given a quadratic function for all x values less than or equal to -3. We're given a cubic function that is not written in a standard form, but it is cubic over the domain -2 to 5. And then we are given an absolute value function for the domain x is greater than or equal to 5. All right. So once again, like I said, we're not going to graph this, although you very well could using tables or a graphing calculator or whatever it is you want to use. So f of -1. So our x value here is -1. So I always ask which of these 3 functions, 1, 2, or 3, does -1 satisfy the domain restriction? Okay, and that's what these are. These are the domain restrictions. All right, and so if you're just kind of new to this, I just plug it into each one. So is -1 less than or equal to -3? No, it is not. So number 1 is out of the question. Does -1 fall between -2 and 5? And we find that it does, okay? Now, since this is piecewise functions and not piecewise relations, then we are, -1 is only going to fit into one of these pieces, right? It's not going to fit into multiple ones. It's going to fit into one of them, all right? So f of -1, so we're going to use the 3x plus x cubed, and I'll have 3 times -1 plus -1 cubed, and that gets us -3 minus 1, which is equal to -4. All right, so there you go. All right, f of 5. Is 5 less than or equal to -3? No. Is 5 strictly between -2 and 5? And the answer there is no. Now, and the way I think of this, let's cover up this piece right here and ask yourself, is 5 less than 5? And the answer is it is not, because 5 is equal to 5. So we look at our last piece and say, okay, well, is 5 greater than or equal to 5? And yes, it is. So we're going to plug in 5 for x. 5 minus 8 is -3. The absolute value of -3 is 3. And then we have this negative sign out here, so we get -3. Okay. Now, finally, our x value in this problem is -2.5, and we are going to check out, which of these functions will it fit into, if any. So is negative 2.5 less than or equal to negative 3? And the answer is no, because the numbers that are less than negative 3 are like negative 4, negative 5, so they go, in the opposite direction. Is negative 2.5 in between negative 2 and 5? And the answer is no, because negative 2.5 is less than negative 2. So it doesn't fit into that one either. And is negative 2.5 greater than or equal to 5? And the answer is also no. So as a matter of fact, we see here that, negative 2.5 is not in the domain of this function. And therefore, we would say that f of negative 2.5 does not exist, or d and e. Okay, and you're going to see d and e a lot in calculus. Okay. All right. Let's move on down to these practice ones. Oh, the reason why I starred these 2, 6, and 7 is because of the question. It says, tell if the functions are continuous. So what I want you to start thinking about, because you're about to start your journey into calculus, what do you think it means for a function to be continuous? Okay, what would a function look like if that function was continuous? So think about it in your head. Think about the functions that you've studied. If you've actually taken, maybe you saw it in Algebra 2 or pre-calculus, but, think about your family of functions, think about rational functions, discontinuities, all that good stuff, all right? Okay, so here we go. We're gonna study these two different piecewise functions, g and h. They both have 3 different pieces to them, and they have the domain restrictions. So g of 1. So I'm actually going to color code these, and let's do a different color. So g will be in purple. So let's see which of these use g. And then we'll do a red for h. All right. So g of 1. Think to yourself, where does this fit in? Which one? The first function, the second one, or the third one? Well, 1 is greater than or equal to 1, so it will fit in that cubic function x cubed minus 5x. So I'm going to plug in 1 and cube it, minus 5 times 1. So you get 1 minus 5, which is equal to negative 4. Okay. All right, g of 11. Well, is 11 less than 11? No. So we can't use that middle function. Is 11 greater than 11? No. So we cannot use the square root function either. And it's definitely not less than 1. So once again, we see a situation where we're dealing with an x value that is not in the domain of this function. So g of 11 does not exist. Okay. For the sake of ease, let's do g of negative 1. So let's look at question number 5. G of negative 1, well, negative 1 is less than 1. So I will plug it into that first quadratic function that I see. So I have negative of negative 1 squared minus 5 times negative 1 plus 2. Parentheses are your friends, guys. Parentheses are your friends, okay? Negative 1 squared is positive 1, and then we throw the negative out front, so we get negative 1. Negative 5 times negative 1 is positive 5, and then plus 2, so what's that? 7 minus 1, so you get 6. Okay. And then g of 20, so I'm going to have that 20 satisfies the domain restriction of that last function. So I have negative square root of 3 times 20 minus 16. So that's 60 minus 16. So what's that going to be? 44? Oh my gosh, I hope I'm not wrong. Yes. Oof. All right. Negative square root of 44. Then 44 breaks down into 4 and 11. 11 is prime, so he's going to stay inside the radical. The square root of 4 is 2, so it's negative 2 root 11. Cool. Now, if you're not good at simplifying radicals, I would also take some time to maybe look up some other YouTube videos on simplifying radicals. All right, let's go to H. H of 5. So where does 5 fit in? Looks like it fits into that last equation, which is like a linear combination. Well, not a linear combination, I apologize. We have a linear term and we also have a absolute value term. So it's gonna fit into there because 5 is greater than 1. So I'm gonna have 2 times 5 minus the absolute value of 5 minus 10. So I have 10 minus 5, which is 5. I did that really quick, so let me go back and check my work. So I have 2 times 5, which is 10. 5 minus 10 is negative 5. The absolute value of that is 5. Then we throw a negative in front of that. Yeah, I'm good to go. All right, negative 10. So negative 10 is definitely less than or equal to negative 6. So I'm going to plug it into this first one, the 2x squared function. So 2 times negative 10 all squared minus 2 times negative 10 plus 1. So this is 200 plus 20 plus 1. So that is 221 is the result there. All right. H of 0. So where does 0 fall? And it looks like 0 falls in, yep, that middle one. It's between negative 3 and positive 1. So if I plug in 0 to 3x, I get 0. So 3 times 0 is 0. Minus 0 cubed, so you get 0. All right, finally, h of negative 4. I am going to, negative 4 is not less than or equal to negative 6. And it's also not between negative 3 and positive 1. So once again, we have an issue where, negative 4 is not in the domain of this piecewise function, so D and E. Okay. And once again, if you missed it the first time, D and E stands for does not exist. And this phrase has been very much popularized in the movie Mean Girls, the limit does not exist. And so hopefully you have heard it before, hopefully in an actual math context, but if not, now you have. So once again, thank you for tuning in. If you have any questions, leave them in the comments below. If you're my student, you can message me in Canvas, and I will see you guys at the next video.